find the position of center of mass of four particle system which are at the vertices of parallelogram. So this is one parallelogram. Actually, this is one parallelogram. They used to mention only masses m, 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 and m. Identical masses are present at the four vertices of the parallelogram. Okay, one of the side is A. Here it's very clearly visible O, and here it's clearly visible capital A. O to capital A, the distance is small a. This given in the problem. O to C, the distance is given in the problem as B. And the angle made by the B with horizontal is theta. With horizontal is theta. Okay, so only this can be mentioned. Only this can be mentioned, right? Now, here we are taking the concept it as, listen carefully. Listen carefully. At first, we need to take coordinates. The first mass is at origin 0, 0. The second mass is on the x-axis, and that's why a, 0, a, 0. And then third mass, if you take this is the third mass, at first this is the B. B is the vector. B is the vector making an angle theta with horizontal. So resolved into components B cos theta, and this is the vertical direction B sin theta. B is the vector which is making an angle theta with horizontal B cos theta, and this is a B sin theta. Okay, now at first this is the mass, third mass. Third mass exactly coincide at capital D. I consider one perpendicular line. It coincides the x-axis at capital D. So from the origin, this is the origin. From the origin to the capital D, what is the distance? From O to A, the distance is A. From A to D, the distance is B cos theta. Then what about the total distance from O to D? A plus B cos theta. This is the x component. A plus B cos theta. Now, and this is the y-axis. BD, y-axis. This y-axis is parallel to B sin theta. This is the vertical component, no? So parallel component, vertical component is B sin theta. This B sin theta is parallel to BD. So BD also equal to what? B sin theta. That is nothing but y component. The mass m at B having the coordinates A plus B cos theta and B sin theta, right? And now come to this part. Again, this B is making an angle theta with the horizontal B cos theta, and this is nothing but B sin theta. Now this point C on the x-axis, it is at a distance of O to this point. This point is, what is the distance here? It's clearly visible, that is B cos theta. B cos theta. And anyway, vertical component is nothing but, what is the value here? B sin theta. Okay, so like this, at first, for any problem, if you want to calculate the position of center of mass, at first we need to take the coordinates. Okay, now based on the coordinates only, we can decide where is the position of the center of mass. Now here we are taking the concept it as four masses are present. So four masses, four coordinates here we are having four coordinates. Okay, now these four coordinates already we mentioned here: x1 y1 0, 0, x2 y2 a, 0, x3 y3, and this is the point A plus B cos theta and B sin theta, and x4 y4 B cos theta and B sin theta. This is the point. Now based on that, I considered one formula for the XCM. XCM is nothing but position of center of mass on the x-axis with respect to x-axis. M1 x1, M2 x2, M3 x3, M4 x4. We need to take the sum. Why? Because four masses, four terms. By total mass of the system, M1 plus M2 plus M3 plus M4. Now, if you substitute M1 value, all are having at the four vertices of this parallelogram having the identical masses M, 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 and M. So M1 is equal to M. X1 is nothing but, this is the X1, 0. M2 is equal to M. X2 is nothing but, what's the value again? X2 is nothing but here, this is A, plus M3 is nothing but M. Then X3 is equal to, this is the X3, A plus B cos theta, plus M4 is nothing but M. What is the X4 here? B cos theta, by total mass M plus M plus M plus M, 4M. Then here 0 into anything equal to 0. Then A, and here also A is present, A plus A, 2A. take out the m as common and cancel numerator as well as the denominator. Okay, that can be over. Now a plus a, 2a, b cos theta, and again here also b cos theta repeated. B cos theta plus b cos theta, 2b cos theta. From this again 2 taken as common, then a plus b cos theta into 2. 2 ones are 2 twos are, then the left part is nothing but a plus b cos theta by 2. Okay, now in the same way, here we need to consider the b sin YCM. Then for YCM is nothing but how come we represent? And just you think about the formula. What is the formula of YCM? YCM is equal to M1 Y1
plus M2 by 2.
Don't tell why, because your voice is recording, no? M2 Y2 M3 Y3 plus M4 Y4 by M1 plus M2 plus M3 plus M4. Okay, now see here YCM is equal to M1 Y1 plus M2 Y2 plus M3 Y3 plus M4 Y4 by M1 plus M2 plus M3 plus M4. Then YCM is equal to, as you know well, here itself coordinates are present. Here itself coordinates are present, right? Now M1 is nothing but M, Y1 is nothing but 0, and this is the 0, plus M2 is nothing but M, Y2 is again 0, plus M3 is nothing but M, Y3 is nothing but this is B sine theta, plus M4 is nothing but M, Y4 is nothing but again I am taking the B sine theta by total mass. What is the total mass? The total mass is nothing but 4M. Then 0 into anything equal to 0, 0 into anything equal to 0, then no need to write these two things. Then YCM is equal to, take out the m as common and cancel numerator and denominator. B sine theta plus B sine theta, that is nothing but 2B sine theta. Then in the denominator, m already cancelled. The remaining part is 4. 2 ones are 2 twos are. Then B sine theta by 2. And this is the YCM. Now, here we used to represent the part is like this. XCM comma YCM is equal to, what is the XCM? Just now we calculated that A plus B cos theta by 2. This is the XCM. We need to write like this, A plus B cos theta by 2. Then what about the YCM? Just now we calculated that B sin theta by 2. And this is the part of this question. That's it. Okay, and now here I'm taking another problem, and this is another problem. If the center of mass of three particles of masses 1 kg, 2 kg, 3 kg is at 2, 2 meters, then where should a fourth particle of mass 4 kg be placed so that the combined center of mass may be at 0, 0, 0? Then it's in this problem it is very clear that how many masses are there? Initially 1, 2, 3. 3 masses are present, having the masses 1 kg, 2 kg, 3 kg. And that's why here I mentioned M1 is equal to 1 kg, M2 is equal to 2 kg, M3 is equal to 3 kg. Okay, now at first I'm taking the case 1. In this problem we have two cases. So at first I'm taking the case 1. In case 1, if only 3 masses are present, concentrate on my words properly. If only 3 masses are present, M1, M2, M3, then what about the position of the center of mass? 2, 2, 2, given in the problem. 2, 2, 2. It means XCM 2, YCM 2, ZCM also 2. Okay, now at first, only 3 masses here I considered in case 1. XCM is equal to 3 terms only. M1x1 plus M2x2 plus M3x3 by M1 plus M2 plus M3. Then what about the XCM? At first, 2. I mentioned in the place of XCM as 2 is equal to M1 is nothing but 1, x1, we don't know the coordinate, plus M2 is nothing but 2, x2, plus M3 is nothing but 3, x3 by 6. If you take the cross multiplication, 6 2s are 12. So x1 plus 2x2 plus 3x3 is equal to 12. This I mentioned it as first equation. Okay, now concentrate case 2. In the case 2, we added a fourth particle to the system. We added a fourth particle to the system. Previously, how many particles are there? Only 3. Now, how many particles are present? 4. Why? Because we added fourth particle. If you add some more mass to the system, then the position of center of mass can be changed. Okay, now concentrate clearly. If you add some more mass to the system, or if you add some more mass from the system, if you add some mass to the system, or if you remove some mass from the system, then the position of center of mass can be altered, changed. Here, adding takes place. In this problem, what happens here? Adding takes place. So the fourth mass is added. What is the mass of the fourth mass? 4 kg. 4 kg. Then what happens to the position of center of mass? 0, 0, 0. Previously, where is the center of mass? 2, 2, 2. Shifted to 0, 0, 0. Why? Because the fourth mass is added. Now, total how many masses are there? 4. And that's why the position of center of mass can be considered as xcm dash is equal to, now 4 masses, 4 terms, m1x1 plus m2x2 plus m3x3 plus m4x4 by m1 plus m2 plus m3 plus m4. Okay, now already I substituted this 1 into x1, m2 2 into x2, m3 3 into x3 plus m4 4 into x4 by total mass 1 plus 2 plus 3 plus 4. Okay, now if you take the cross multiplication, anything into 0 equal to 0. I consider this denominator towards like this, cross multiplication. Now, what happens here? Already first equation already we have seen here. What is the first equation? x1 plus 2x2 plus 3x3 is equal to what's the value? 12, right? This value can be replaced in this equation. x1 plus 2x2 plus 3x3. Here also x1 plus 2x2 plus 3x3. What's the value here? 12. And here also you keep here 12. 12 plus 4x4 is equal to what's the value? 0. Then take this 12 to that side, then minus 12. x4 is equal to what's the value? Minus 3. Now, here, what is the YCM? 2. Here, what is the center of mass after changing its value? 0. What is the ZCM? 2. After change its center of mass position, what's the value? 0. It means in the initial case, 2, 0. In the remaining cases also 2, 0. And that's why y4 also equal to minus 3, z4 also equal to minus 3. These are the coordinates of fourth mass. Thereby, the center of mass became 0, 0, 0. Like this, we have to do this problem. Okay, and now I will take another problem. And in this problem, 2 masses are suspended by using the string and passing, the string is passing over the pulley. Okay, actually this topic is in the laws of motion. This topic is in the laws of motion. The topic name is Atwood machine. Okay, now the part we will get here. Some part of this laws of motion we will get here. Okay, so in physics, from one lesson to another lesson, we can jump by using the formula. We can jump by using the content. Okay, so all together, if you have the grip, and then only we will get the idea to do the numerical. Okay, at first get the confident to get the grip. Now, 2 masses m1 and m2. Here mentioned that m1 greater than m2 are connected to the ends of massless rope and allowed to move as shown in the figure. The acceleration of the center of mass is, it's very clear. It's very clear. Once again, I'm explaining here. m1 greater than m2. This mass is greater than this mass. So this mass is moving downwards, and whereas this mass is moving upwards. So whichever is greater, that moves downwards. Whichever is lesser weight, that moves upwards. Okay, so you know very well. Now, With what acceleration? Both the bodies are tied to a string, single string. This is the single string. Okay, so both the bodies are tied to a single string. So both can be moved with the same acceleration, but one is moving downwards, the other one is moving upwards. That's very clear. Now, at first we need to calculate the acceleration of center of mass, ACM. ACM. What is the formula? The formula is m1a1 plus m2a2 by m1 plus m2. ACM is equal to, what's the formula? m1a1 plus m2a2 by m1 plus m2. Two bodies are present, two terms are present. Two terms are present. Okay, and now here I'm mentioning that one body is moving downwards, the other body is moving upwards, right? So now at first, for that purpose, ACM is equal to the one which is moving downwards, you take as positive. The one which is moving downwards, take positive. The one which is moving upwards, you consider it as a negative. So this value is positive plus, and this value is negative. Why? Because A2, this is A1 is equal to A, and this is A2. A2 is equal to, what's the value? Minus A. So minus A and M2 as it is by M1 plus M2. No change in that. Then ACM is equal to M1 A1 plus into minus, minus, and that's why here minus M2 A2 by M1 plus M2. One is A1, the other one is A2. A1, A2 we mentioned, but both are having same acceleration, no? A1 is equal to A, A2 is equal to minus A, and that's why M1 A minus M2, A2 replace with A again by M1 plus M2. Now ACM is equal to A, take as common, then M1 minus M2 you will get here by M1 plus M2. Now this is the actual formula of acceleration of center of mass in this case. This is the actual formula. But here in the case of Atwood motion, just you recapture of the laws of motion. In case of Atwood motion, in this topic, you will get the acceleration formula. Acceleration is equal to, what's the formula? M1 minus M2 by M1 plus M2 into G. With this acceleration, both the bodies are moving downwards as well as upwards. This is the general formula. This is general formula. A is equal to M1 minus M2 by M1 plus M2 into G. Substitute this A value in this equation. What's the value? ACM. ACM is equal to M1 minus M2 by M1 plus M2 into A. A replace with, this is the formula. M1 minus M2 by M1 plus M2 into G. Now M1 minus M2, what's the value? M1 minus M2 whole square by M1 plus M2, M1 plus M2 whole square. The numerator having whole square, the denominator also having whole square. So I am mentioning it as ACM is equal to M1 minus M2 by M1 plus M2 whole square into Z. Okay, this is the acceleration of center of mass. Next, I'm taking another problem. This is another one. Two bodies of 6 kg and 4 kg masses have their velocities 5i cap plus minus 2j cap plus 10k cap and 10i cap minus 2j cap plus 5k cap respectively. Then the velocity of their center of mass is. Okay, so now here we need to calculate the velocity of the center of mass. For that, here I am considering that VCM is equal to just Rewind this problem. M1 V1 plus M2 V2 by M1 plus M2. Now that is equal to, listen. Okay. Now this is the problem. Two bodies of 6 kg and 4 kg masses have their velocity 5 I cap minus 2 j cap plus 10 k cap and 10 I cap minus 2 j cap plus 5 k cap respectively. Then the velocity of their center of mass is VCM. VCM here we are taking the formula as VCM is equal to, what's the formula? M1 V1 plus M2 V2 by M1 plus M2. Why? Because two bodies are there. Two bodies are having different masses, different velocities. That's why I considered this formula. Now, M1, what is the M1? 6 kg. M1 is 6 kg. 6 V1, 5 I cap minus 2 j cap plus 10 k cap plus M2, 4 V2. What is the V2? 10 I cap minus 2 j cap plus 5 k cap by M1 plus M2, 6 plus 4. Now 6 5s are 30, I cap, 6 2s are 12, j cap, plus 6 10s are 60, k cap, plus 4 into 10, 40, I cap, 4 into 2, 8, j cap, 4 into 5, 20, k cap by 10. Now 30 I cap plus 40 I cap, 70 I cap, minus 12 j cap, minus 8 j cap, minus 20 j cap, minus 20 is A cap, 60 K cap plus 20 K cap, 80 K cap by 10, by 10. Now, from the numerator, take the 10 as common, and then you will get 7 I cap minus 2 J cap plus 8 K cap. The numerator 10 as well as denominator 10 get be cancelled, and this is VCM. Here all are in vector representation, so we need to consider as vector representation VCM bar. Why? Because here I cap, J cap, K caps are present, and this again VCM bar. In the problem, whereas in the options, if you find the formula as a number without having vector representation like I cap, J cap, and K caps, then we need to consider like this: modulus of VCM bar is equal to root over 7 square plus 2 square plus 8 square. Even though here minus is present, at the time of calculating the magnitude, we need to consider plus only. Plus only. So VCM is equal to root over 49 plus 4 plus 64. And that is equal to root over 49 plus 4, 53. 64, 53, 7 and 11, 117, 117 VCM. These all are in SI unit, and that's why here I am mentioning it as meter per second. And this is the formula. Okay, now. Another one. Read that numerical. If a wire of length L is bent in the form of a ring, circular ring, then the shift in the center of mass is. So we need to consider the shift in the center of mass topic here. Shift, how much shift can be considered? For that, at first here I'm taking, this is the straight line, nothing but wire. The length of the wire is L. The length of the wire is L. Exactly for the regular bodies, in most cases, the center of mass present exactly at the center. This is the position of center of mass. Okay, now this wire is bent in the form of a circle. This wire is bent in the form of a circle. So I consider this is the circle like this. Circle. It means this is the position, this position of the particle remains same. There is no change. But the thing is nothing but the entire part of the wire can be bent in the form of circle. So what happens here? For the circle, where is the center of mass? Exactly at the center. So the position of center of mass changes from here to center. What is the center here? Nothing but that is the radius of the circle. Radius of the circle. So now what about the circumference of the circle? L is equal to, what's the value? 2 pi r. L is equal to, what's the value? 2 pi r. Now with that, how much shift takes place? Radius here to here. Then r is equal to, what's the value? L by 2 pi. And this is the shift in the center of mass. R is equal to L by 2 pi. Okay, then see the next problem. See this. The distance of the center of mass from the point O is. This is one of the different model. One of the different model this is. At first here, initially you can say it as the length of the rod. The length of the rod is L. What is that? The length of the rod is L. Like this is present actually. Like this. This is the length of the rod. What is that length of the rod? L. L is the length of the rod. Okay. Now the wire can be nothing but either wire or rod. Here I consider that that's a rod. The rod is bent in such a way that it makes an angle theta at the center. Theta at the center. This is the center. This wire bent exactly at the center. This wire bent exactly at the center like this shape. Like this shape. So L became half. Exactly center if you bend, this became half. This is L by 2. This entire part is L by 2. Observe carefully. And this entire part is L by 2. Okay. Initially, what is the length of the rod? L. Capital L. Exactly it bends at the center. At the center. So that length also became half. L by 2. L by 2. Now, two different parts we are observing here. Two different parts. This is one part and this is another part. Two different parts, we need to consider two different center of masses. Two different center of masses. To this part, the center of mass exactly lies at the center. Here. To this part, the center of mass lies exactly at the center. Somewhere here I considered. Here. Now, all of you observe carefully. And this is here. And this center of mass is here. Center of mass is nothing but how come we considered that? Exactly center of this. What is the length? L by 2. L by 2 now. So exactly center means what is the meaning of that? And this is L by 4. And this also equal to L by 4. From here to here L by 4. From here to here L by 4. Why? Because here we considered exactly at the center of that particular rod. So the length of the rod is L by 2. In that center is nothing but this is that. And then remaining part of both sides L by 4 and L by 4. Here I consider L by 4 this. And this also equal to how much? L by 4. Now I am taking one line which combines these two center of masses. These two center of masses. Okay. I am combining these two center of masses. These center of masses here I am taking it as, for example, this is P and this is Q. This P and Q I am combining with a line. With a line. Okay. Thereby what happens here? Now I need to calculate the distance of the center of mass from the point O is. This is the point O. From here to here I consider one bisector like this. It means observe carefully. This is one dotted line. This is P and this is Q. P, Q. Just I consider like this. Now, and this is the point O. O is here. O. Observe. Nothing is new here. Everything is here itself. This is O. O, P, and this is Q. Straight line. Now, on this straight line PQ, the center of mass exactly lies at the center. Nothing but if the wire is like this, straight wire, straight rod, if the rod is like this straight line, then the center of mass is exactly at the center. Now that rod is bent in different ways like this. At that moment, what happens? Two different parts, two different center of masses, two different center of masses. One center of mass is P, another center of mass is Q. On this rod, on this rod. Combine these two points, these two center of masses with a line, dotted line. On this dotted line, the system center of mass is present. New center of mass, this is. It means from here, previously old center of mass is here. From here to here, it can be shifted. It can be shifted. This we need to calculate. This dotted line we need to calculate. It means this straight line, whatever we mentioned, this we need to calculate. This is O, and here I'm naming it as O dash. O dash. Here I need to calculate. For that purpose, here I'm taking further. It is very simple. Nothing is new. Total angle, what is the total angle here? Theta. Exactly half. In this half, I considered. And this is theta. This is theta. In this half, nothing but what is the value? This is theta by 2. And this also equal to theta by 2. Total theta. Then that angle can be divided into two parts. Exactly center. Theta by 2, theta by 2. Now with that, here I am taking the concept as sine, I'm taking the concept as cos theta by 2 is equal to cos theta by 2 is equal to adjacent by hypotenuse. So this is a right angle. This is right angle. So to this angle, this is adjacent and this is a hypotenuse. This is hypotenuse. So for that purpose, here I am taking that cos theta by 2 is equal to cos theta by 2 is equal to adjacent is nothing but this is the value x. X I consider that is the adjacent. And then, and what about this value? We mentioned it as L by 4, x by L by 4. Now x is equal to what's the value? X is equal to cross multiplication. L by 4 cos theta by 2. X is equal to L by 4 cos theta by 2. Nothing is new here. Very simple. First, one straight wire, nothing but rod. After that rod bent at its middle. Two parts we observed. Take the center of mass of one part, P, another part, Q. Combine these P and Q with a dotted line. The new center of mass is present on this dotted line. That is O dash. This after bent into two parts, then one is L by 2, the other one is L by 2. Exactly half from here to here. L by 2 by 2, L by 4. L by 2 by 2, this is half, L by 4. Theta exactly turned into two equal values, theta by 2, theta by 2. Now with that cos theta by 2 is equal to adjacent by hypotenuse. Adjacent is nothing but this is O dash. Here O dash is equal to what's the value? O dash is equal to x. O dash is equal to x. Adjacent is x. Hypotenuse is and this is the value. What is the value? L by 4. Then cos theta is equal to x by L by 4. X is equal to what's the value? L by 4 cos theta by 2. Okay, now observe. Okay, now take another problem. Take another problem. Two bodies of different masses, 2 kg and 4 kg, are moving with velocities 2 meter per second and 10 meter per second towards each other. Towards each other. This is very, very important term. towards each other. That is important term. Then the velocity of the center of mass is. Okay. Now listen. Two bodies of different masses, 2 kg and 4 kg. M1 is equal to 2 kg. M2 is equal to 4 kg. Moving towards each other. So for example, this is one body, M1, and this is another body, M2. And these two bodies are moving towards each other like this. Like this. So when both the bodies are moving towards each other, then it means what? One is moving with the velocity v1, the other one is moving with the velocity v2. Simply we used to say that towards each other means both are moving in the opposite directions. How come we say that? Opposite directions. So the velocity of the center of mass VCM is equal to, take the formula m1 v1. If both the bodies are moving in the same direction, consider plus. But if the bodies are moving in the opposite direction, straight away you take the formula minus m2 v2 by m1 plus m2. M1 plus m2. In general, here we need to consider the difference symbol, difference. Whichever is higher, from higher to lower, we need to subtract. Okay, now VCM is equal to m1. What is the mass of the first one? 2 kg. What is the velocity? Given that 2 meter per second plus, I'm taking the difference symbol, m2. What is the m2 here? 4. v2. What's the value? 10. By m1 plus m2, 2 plus 4. Now to